Class, for your homework, the first part of your homework, I want you to go ahead and you could go to page 465 and write down the definitions and find at least one example of each of these definitions. Just because I don't want to spend this whole video talking about these definitions. I'll kind of recap them when you get back to class. So let's just kind of move on to the next page, and you'll hear me using these words, and hopefully you'll kind of start catching on, but I don't want to spend time just defining these words during this video. Now let's kind of get to the meat of the idea of these two sections. So this is still section 1, 8.1. And honestly, this is the same thing as combining like terms. Now, if you look at number 1, this long polynomial, there are 5 monomials being added and subtracted together. Now, even though there's the same variable x, we have taught you that you can add all the same variable x's. However, that is only half true. Because now that we're dealing with polynomials, you can only combine, add or subtract, monomials of the same exact degree, meaning the same exact exponent. So if you look here, I'm going to underline with different colors. I have two terms that are common right here because they're both x cubed. And then in red, I'm going to circle the x squared. And then in green, I'm just going to put a box around the constants, the numbers that doesn't have a variable. Now these are the ones that can be added together, these color coding. So my x cubes can only go with x cubed. So negative 5x cubed plus 7x cubed turns out to be 2x cubed. A positive 2x squared plus another x squared gives me a 3x squared. And then since minus 4 doesn't combine with anything, we just have minus 4. And this right here is my answer completely simplified. Now, I'm going to tell you that it is very important to have your degrees in decreasing order, meaning your cube comes first, then your squared, then your x to the first power, and so on and so forth. That is very important in mathematics. So we'll go ahead and try number 2. If you recognize that, well, this one's kind of an easy one. Only the x's go with x's and the y's go with y's. Okay? The next sentence here, again, it just says that make sure, if it is a polynomial, find the degree and determine whether if it is a monomial, binomial, or trinomial. So this is an application of the actual vocabulary words. Okay? So I'm going to actually assign this one for homework as well, and we'll talk about that when you come back to class. Let's jump down to example 2. This statement in italics is just re-emphasizing what I had already said. When you get a final answer, okay, you need to make sure this right here is not in correct order. You need to make sure that it is in decreasing order in terms of your exponents, the degrees. Okay? The directions here says write each polynomial in standard form, identify the leading coefficient. The leading coefficient is the first monomial. What is his coefficient? That is my leading coefficient. Okay? If you move down a little bit, now we're just going to add. We have two trinomials, and we're just going to add these two. Now the first method is just adding horizontally. I'm going to underline all my x squares. I'm going to circle all of my xy's. And I'm going to box all of my y squares. And I'm going to kind of rearrange my whole polynomial so that I have all my common terms near each other. And then I'm going to combine my like terms. So my final answer is 10x squared plus 11xy minus 5y squared. Now, you might be wondering, wait, doesn't 5y squared have a higher degree than 11xy? So it's kind of a weird rule now that I think about it, because my x's are the ones, in alphabetical order, x comes first and then y, right? So my x's are the first ones that take priority, so that one has to go decreasing order. And then once I have my mixture of y, then I go in increasing order. If you don't really get that, we'll kind of get used to it, okay? Now method 2 is just the vertical method. So very similar to actually doing the process of elimination, the solving systems by equations by elimination. Just make sure that all of your like terms line up with one another, and you'll actually find that you'll get the same answer. So whichever one you prefer, it's completely up to you. Now, subtracting is pretty much the same, but there's one small trick that might get a lot of people. So let's scroll down a little bit. Now you got to be careful because this first polynomial says you're subtracting this from the second. And so what that means is the second one comes first minus that first one. So if we do it horizontally, the setup will look like this. The first one minus the second one. Now why is this important? Because for subtraction, as we know, when there's a minus, that will actually have to get distributed to all the different signs into the second one. And so really what we'll have is 3x squared plus x squared minus 5xy minus 6y squared plus 3. And so if you combine the like terms, you'll notice it's all the same thing. And then go ahead and combine those like terms and see what you get. There's my final answer. Doing it vertically is pretty much the same. You just got to be careful of distributing that minus sign. So let's scroll down, and we're actually going to jump to section 2. What we just learned combining like terms is section 1 of chapter 8. Now the question says find the product of x times x plus 4. And so if you think of this as an area of a rectangle, right? And so we have this rectangle here. My width is x and my length is x plus 4. And so we actually kind of split it we split it right here where this is an x and this is a 4, and so x plus 4. Now if you multiply this x with this x with this x, then you get x squared. And even if you multiply this x with this 4, you get 4 times x, which is 4x. And so we get x squared plus 4x. Now, visually, that might be a little bit confusing. Okay, so if you scroll down, I can show you algebraically how this works. You are using the distributive property to multiply polynomials by monomials. And so if you look at this horizontally, and I actually prefer horizontally, you have x times the group x plus 4. So x times x gives you x squared, right? Because if we remember from chapter 7, x to the first power times x to the first power, they have the same base, so I add them and I get x squared. X times 4 gives me 4x. So that's honestly the easiest way. I usually don't use vertically x plus 4 times x. It's totally possible, but to be honest, from here on out, I'm just going to use the horizontal. And so if we look at this first example, negative 3b times the quantity 2b squared plus 4b minus 1, there should only be one parentheses there. And so you're going to distribute this negative 3b into the group, and negative 3b times 2b squared is negative 6b cubed. And negative 3b plus 4b gives you a negative b squared. And then a negative 3 times a negative 1 gives you a positive 3b. And again, since none of these are actually like terms, that's what we have here. Oop, I'm realizing I messed up on the second one. Looks a little bit better. Now, why don't you try this one on your own? I'm going to give you a hint. Start by distributing the inside here. Okay, that's going to be your homework. That's going to be another part of your homework. I'm going to check that when you get back to class. Why don't you also do the bottom two as homework, because this is honestly review. I want you to do numbers 1 and 2 and 3 as homework. Change this one to horizontal if you prefer. I would prefer it to be horizontal. And I'm going to do number 4 together with you right now. So 4y times y squared, I need to distribute this 4y. And so 4y times y squared gives me 4y cubed minus 8y squared plus 4y. And so when I distribute, that's my new trinomial. Okay, so numbers 1, 2, and 3 is also going to be homework that I'm going to be checking. And let's also just say numbers 5 and 6 will also be homework. So I know with the notes, I just want you to just try to practice. If you need some help, actually, let's do number 5 together. Okay, sorry about that. Number 5, it is a little bit crazy. So I have 3pq squared times 2p squared q minus blah, 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 blah. And so you kind of have to go little by little here. Now 3 times 2 will still give you 6. P times p squared will give you p cubed, right? Because p to the first power plus the second power gives you 3. And then q squared times q to the first will also give you q cubed. Minus 3 times minus 1, which is just 3. P to the first power times p to the first power is p squared. Q to the second power times q to the first power gives you q cubed. And 3 times 5 gives you 15. P to the first power times no p just gives you p. Q squared times q squared gives you q squared. And so there, you kind of have to break the variables apart little by little and remember those properties. So why don't you try number 6. I mean, this one again is quite a bit of review. Okay, so that's actually sections 1 and 2. So that's not too bad. We're gonna just spend Monday on those things, or one day on those things, and then I'll give you your homework when you come into class the next day.